Hi everyone, in this video I'm just going to go through my strategy for, here are just some examples that I created. So again, I don't recommend you try to memorize the unit circle and memorize all these. There's just too much, and all you really need to be able to do is quickly create what you need to answer a question. Now, the one memorizing I will say that I have done is, if you think about the unit circle, you do need to memorize the x and y values, or the sine and cosine, just for quadrant 1. And there are different tricks for this. Some of the videos I put on Classroom go through one of the tricks. But I always just remember anything with a pi over 4 or a 45 degrees, these in the middle, these are always square root of 2 over 2. So wherever you are on the unit circle, right in the middle is going to be your square root of 2's over 2's. And then you just got to remember, well, over here, the cosine is negative and the sine is positive. Over here, cosine and sine are both negative. Over here, cosine is positive, sine is negative. So for these other ones, which I kind of call the messy ones, I always just remember this first one that I come to, which is going to be pi over 6. I always say that's the messiest one, because I think this square root of 3 over 2 is the most complicated. So I just remember, well, it's this first one you come to. Messy comes first. Square root of 3 over 2 is the messiest one. 1/2 is not too bad. And then, so this would flip-flop. So really, this is all I remember. It's going to be the same down here too, but all I need to remember is pi over 6, or the first angle I come to, the messiest coordinate comes first. So there's some other tricks. I'll show you this one again here. So I'm going to divide my quadrant 1 up into 3 sections, and I know I'm going to have 3 coordinate points for these. And they all have a 2 in the denominator, so you can start out by thinking they all are over 2. And the trick for this one is you count 1, 2, 3, and 1, 2, 3. And then you put square roots over everything. Well, the square root of 1 is just 1, so that stays. Square root, square root, square root, square root of 1 is 1. So that's another trick. Really, that's about all I memorize. Now, let's look at some of these examples. So if I have pi over 4, well, first thing I remind myself is anything over 4 is going to be some version of square root of 2 over 2. And then if I realize this is in quadrant 1, then I know it's going to be positive square root of 2 over 2, so I'm done. But say I didn't realize the quadrant, this is what you can think about for pi over 4's. This is taking, think the top half, because from 0 to here is pi. I think most of you know that. So this is saying I'm taking the top half of the unit circle and dividing it into fourths. So there's 4 sections. This is 1 pi over 4. This is 2 pi over 4. I don't know why I wrote 2 there. Should have wrote 4 there. This is 3 pi over 4. This is 4 pi over 4, which simplifies to pi. This 2 pi over 4 simplifies to pi over 2. And you could do this around the whole thing. Say you had a 5 pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4 is right here. 6 pi over 4, 7 pi over 4, 8 pi over 4, which would just be 2 pi. And then I already have my coordinates from over here, so I know pi over 4 is right here. The cosine and sine of this angle are both square root of 2 over 2. Okay, say this is my next one. It's an over 3. So anything over 3 is some form of a pi over 6. If you wanted to, you could multiply the top and bottom of this by 2 to get it to be a pi over 6. So pi over 6 is taking, again, the top half of the unit circle and dividing it into 6 pieces. So 1, 2, 3, 4, 5, 6. So this would be 6 pi over 6, which is just pi. So I'm looking for 8 pi over 6. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6. This is my 8 pi over 6, which simplifies to 4 pi over 3. Okay, so I know I'm here at this angle. And if I remembered my trick over here, this is going to be the same. So from here to here, I'm doing the same thing, but down here. So the coordinates of this point are going to start out with 1/2 and the square root of 3 over 2. Both are going to be negative. So the sine of 4 pi over 3 is going to be, this is the cosine, this is the sine, negative square root of 3 over 2. Okay, another, let me just show you this while I'm on here. So this would be your 45s would be between there. So I said over here, this first one is the ugliest one. This goes for all the sides. So this is a square root of 3 over 2. This up from here is a square root of 3 over 2. This one starts with a square root of 3 over 2. So I know this one starts with a 1/2. Okay, let's do the next one. This is a negative 7 pi over 6. So it's already got the 6 on the bottom. So I'm just going to do what I normally do. And I want 7 pi over 6 in the negative direction. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. Oh, I made a mistake. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. This is 7 pi over 6. Oh, well, wait a minute. That's in the negative direction. So that's going this way. So what I want, well, I could do two things. I could say, well, I remember this point or this angle always starts with the ugly one, and then the 1/2 will be second. This would be negative. This would be positive. So cosine would be negative square root of 3 over 2. The other thing I could think is the positive angle here would be 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. So this is the same as 5 pi over 6 in the positive direction. Okay, let's do secant, 3 pi over 4. Okay, it's a pi over 4. So I know it's some form of square root of 2 over 2. Secant, when I say the word secant, I do not say cosine. So this is 1 over cosine of 3 pi over 4. So I want to find cosine of 3 pi over 4 and take the reciprocal or flip it. So remember, pi over 4s are, I'll do a different color here, 1 pi over 4, so they're dividing it into 4. So that's 1 pi over 4, 2 pi over 4, 3 pi over 4. Oh, 3 pi over 4, that's what I'm looking for. So this is 3 pi over 4. Both coordinates are going to be square root of 2 over 2. The first, the cosine is going to be negative. So I'm going to flip, because I want 1 over the cosine of 3 pi over 4. So I'm going to flip this, and I'm going to get negative 2 over the square root of 2. In calculus, we don't have to rationalize the denominator, but most of the time this will be rationalized. So it would look like this, which would simplify just into the negative square root of 2. Okay, one more. Negative again. It's a 3 on the bottom. I'm going to turn it into a 6 on the bottom. So what I'm looking for, oh crap. Oh, okay, sorry, thought my Thought my video stopped. What I'm looking for is negative 10 pi over 6. Okay, so I'm just going to do my counting in the negative direction, see where I end up. 1 pi over 6, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm up here. This is actually at pi over 6, or 60 degrees. The coordinates of this are 1/2 square root of 3 over 2. Everything positive. Okay, so I know where I am. Now what I'm finding is cotangent. So this is actually another thing you need to remember. Tan is sine over cosine. Cotan is cosine over sine. So the cosine of this angle is 1/2 divided by the sine, which is square root of 3 over 2. So then I'm going to do keep, change, flip. It's going to be 1/2 times 2 over the square root of 3, which would just be 1 over the square root of 3. If I rationalize the denominator, multiply top and bottom by square root of 3, I get square root of 3 over 3. Okay, that's it.